Hey everyone, welcome back to the channel. Imagine you just developed an amazing app with your friends, but it's taking forever to launch because the developers and operations teams are struggling to coordinate. Sounds frustrating, right? That's where DevOps comes in. Today we will show you how DevOps bridges the gap between development and operations. By the end of this video, you will not only understand what DevOps is, but you'll also see how it's transforming the way companies develop and deliver software. We'll talk about every phase of DevOps with real-world examples, along with its benefits, challenges, and future scope. Let's get started. So first thing first, what exactly is DevOps? It's a game changer in software development and operations, bridging gaps and enhancing efficiency. Let's dive in and understand what DevOps really is all about. Imagine you're building a really cool app with your friends. One group of friends, the developers, are writing all the code. They are the creative brains behind the app. Another group, the operations team, ensures the app runs smoothly on everyone's device. Traditionally, these two groups work separately, often leading to misunderstanding and delays. DevOps is like the bridge that connects these two groups, enabling them to work together seamlessly. It's more than just a process, it's a culture that fosters collaboration and innovation every step of the way. Think of it like a well-coordinated sports team. Imagine a soccer team where the strikers, the developers, and goalkeepers, the operations, practice separately. The team would not perform well because they were not in sync. But if they practice together, they can anticipate each other's moves and plays much better as a unit. That's what DevOps does for software development. It brings together everyone, enhancing communication and collaboration. Let's discuss the DevOps lifecycle, which consists of 8 stages: plan, code, build, test, release, deploy, operate, and monitor. To illustrate, we'll use the example of developing a mobile banking app. So first stage is plan. This is where the project planning and requirements gathering take place. The team decides what features the mobile banking app needs, such as checking account balance, transferring money, and paying bills. They set goals and define the scope of the project. Second stage is code. Developers start writing the code for the app. They use version control systems like Git to manage changes and collaborate with other developers. For example, one developer might work on the login functionality, while another can work on the transaction history feature. So they both collaborate and work together in this phase. Third is build. The code is then built into a deployable format. This involves compiling the code and packaging it into an application file like an APK for Android or IPA for iOS. Jenkins can be used here to automate this process, ensuring that every new piece of code is integrated smoothly with the existing code base. Fourth stage is test. Automated tests are run to ensure the code is functioning correctly. Continuous testing helps catch issues earlier. For our mobile banking app example, this might include unit tests to check individual functions, integration tests to ensure different parts of the app work together, and UI tests to verify the user interface behaves as expected. Okay, next phase is release. The application is prepared for deployment. This involves creating release packages that can be deployed to production. In our example of a mobile banking app, the app is packaged and signed, making it ready for submission to app stores like Google Play or Apple App Store. Next or sixth stage is deploy. The application is deployed to a production environment. Tools like Docker, Kubernetes are often used to manage the stage. For the mobile banking app example, this means releasing the app to the App Store, where users can download and install it. Next phase is operate. The application is run in a live environment. Monitoring and logging tools help keep an eye on the system's health. For instance, the operations team ensures that the app servers are running smoothly, that users are not experiencing any downtime. Next stage is monitor. Continuous monitoring provides feedback from the production environment, ensuring the application is performing as expected and helping identify any issues. For our app example, monitoring tools can track performance metrics like response time, error rates. If the app is running slowly or users are encountering any errors, the team can quickly address these issues. So these were all the stages of lifecycle. The beauty of DevOps lifecycle is that it's an infinite loop. After monitoring, the feedback is used to plan the next set of improvement or features, and the cycle starts again. So that was all about the DevOps lifecycle. DevOps rests on several fundamental principles that drive its success: collaboration, automation, continuous integration, continuous delivery, and monitoring and feedback. These are not just buzzwords. They are the pillars that support every successful DevOps practice. Let's start with CI/CD, continuous integration and continuous delivery. Continuous integration means developers frequently merge their code changes into a central repository where automated builds and tests run. Picture it like this. Instead of waiting for everyone to finish their work and then trying to put it all together at once, they are adding their piece of puzzle one by one, ensuring everything fits perfectly along the way. Continuous delivery takes this further by automatically preparing these changes for release. Think of it like an assembly line in a factory. As soon as a piece of code is ready, it's packaged and moved along the line until it can be shipped to the users. This means new features and updates can be delivered quickly and reliably. Now, it's also important here to talk about the tool that is helping with CI/CD, and that's Jenkins, one of the most popular tools for implementing CI/CD. Jenkins is like the automation butler for your software project. It helps automate the building, testing, and deploying of your code. Imagine you are a chef preparing a big feast. Jenkins is the sous chef who ensures all the ingredients are prepared, the dishes are cooked to perfection, and everything is served on time. For instance, when a developer pushes new code to the repository, Jenkins can automatically run tests to check if the code is working correctly. It can deploy the code to production if everything looks good, making the whole process smooth and efficient. Next up is Infrastructure as Code, or IAC. Imagine you had to build a Lego set without instructions. It would take a quite longer time, right? IAC provides those instructions, but for IT infrastructure. Instead of manually setting up servers and networks, which can be time-consuming and error-prone, you write code to automate these processes. It's like having a blueprint that ensures everything is built exactly the same way every time. For instance, let's say you're setting up a website. With IAC, you can write a script that automatically creates and configures the web server, database, and other necessary components. This not only saves time, but also reduces the risk of mistakes. Now let's talk about one of the most popular IAC tool, that is Terraform by HashiCorp. It allows users to define infrastructure through declarative configuration files, which can be used to create, manage, and update infrastructure resources across a variety of providers, including AWS, Google Cloud, Microsoft Azure. Another crucial aspect of DevOps is monitoring and logging. Imagine you are driving a car without a dashboard. You would not know how fast you're going, if you are low on fuel, or if the engine is overheating. Monitoring and logging provides that dashboard for your software. They help you track the performance of your application and identify any issues before they become big problems. For example, if users are experiencing slow load time on your website, monitoring tools can alert you to the issue and even pinpoint the causes, whether it's slow database query or a server that's running out of memory. Logging keeps a record of all the actions and events within your system, so you can go back and see what happened if something goes wrong. It's important here to talk about the two tools, Prometheus and Grafana. Talking about Prometheus, born in the bustling tech halls of SoundCloud, Prometheus steps up as a stellar open source toolkit tailored for system monitoring and alerting. It shines when handling time series data, capturing metrics with precision. But that's not all. Prometheus is equipped with a robust query language that allows you to dive deep into data, spotting trends, anomalies with ease. Even something out of the ordinary pops up, it doesn't just note it. It alerts you, ensuring you're always in the know and ready to act. Next is Grafana. When paired with Prometheus, Grafana becomes the visual storyteller of data. This open source platform transforms the complexity of monitoring and observability into clear, actionable insights. With Grafana, you're not just collecting data, you're engaging with it. Query, visualize, and trigger alerts on your metrics regardless of where they reside. Whether it's sleek charts or detailed graphs, Grafana connects seamlessly to your data source, bringing your data to life right before your eyes. Let's talk about the next two tools, that is Docker and Kubernetes. Effective implementation of DevOps principle hinges on utilizing the right tools. Hence, let's talk about Docker and Kubernetes, two of the most popular tools in the DevOps toolkit. Docker is like a shipping container for your software. Just like containers keep goods safe and standardized during shipping, Docker packages your applications and their dependency into a container that can run anywhere from your local machine to a cloud server. Docker can be integrated with various CI/CD tools to automate the testing, building, and deployment of applications, making the process faster and more reliable. Docker is particularly influential in development build, and testing phase of DevOps lifecycle. Kubernetes, on the other hand, is like a logistics manager for these containers. It helps you manage and orchestrate all your containers, ensuring they are running smoothly, scaling up when there is high demand, and recovering quickly if something goes wrong. Imagine you're running a fast food chain. Docker would be the individual burger boxes, and Kubernetes would be the system that ensures every restaurant gets the right number of boxes at the right time. Kubernetes excels in the deployment phase and operate phase of DevOps lifecycle. Lastly, let's talk about automation. Automation is a cornerstone of DevOps because it reduces manual effort and minimizes human error. Think about doing your homework with the help of a robot that can instantly solve math problems and write essays based on your input. That's what automation does for software development. For example, automated testing can run hundreds of tests on your code in minutes, ensuring everything works correctly before it goes live. Automated deployment tools can take your code and deploy it to servers with a click of a button, making the release process faster and more reliable. So we have talked about the what and the how. Now let's chat about the why. Let's talk about some benefits and maybe a few challenges of DevOps. So what are the benefits of using DevOps? Firstly, it speeds up the software development process. By automating tasks and improving collaboration, new features and fixes can be delivered faster. Secondly, it improves reliability. With automation testing and monitoring, you can catch and fix issues before they affect users. Thirdly, it enhances scalability. Tools like Docker and Kubernetes make it easier to scale your application to handle more users. Now, of course, adopting DevOps is not without its challenges. One major challenge is cultural change. Teams need to shift from working in a silos to collaborative approach, which can be difficult. There's also the learning curve associated with new tools and technologies. Finally, integrating DevOps practices with existing workflows can be complex and time-consuming. Now let's talk about the future and advancements in DevOps. As technology evolves, so does DevOps. One of the exciting areas is the integration of artificial intelligence and machine learning. AI and ML can analyze vast amount of data from your deployment and operation processes, providing insights and automating even more tasks. For instance, AI can predict potential issues before they happen, allowing teams to proactively address them. Another advancement is the rise of DevSecOps, which integrates security practices into the DevOps process. Traditionally, security was often an afterthought addressed at the end of the development cycle. With DevSecOps, security is built into every stage of development, ensuring that applications are secure from the ground up. And let's not forget about serverless computing, which allows developers to build and run applications without having to manage the underlying infrastructure. This can significantly speed up development and reduce cost. So to wrap things up, DevOps is all about collaboration, efficiency, and automation. It's like building a car assembly line for software development, ensuring that everything runs smoothly and quickly from start to finish. By adopting DevOps practices and tools like Jenkins, Docker, and Kubernetes and staying updated with future advancement, companies can deliver better software faster and more reliably, despite the challenges. So it's not just about new tools, but also about new mindset. I hope this helped demystify DevOps for you. If you have any questions or want to learn more about specific topics within DevOps, leave a comment below. Don't forget to like, subscribe, and hit the bell icon to stay updated with our latest videos. Thanks for watching, and I'll see you in the next one.